Was this 11-1? That's what he told me.
Okay, this is Tech Math 3 and Pre-Calculus combined. We're in section 11-1, and we have a rule. And the rule is the rule of sines, law. Now, law of sines. Now, in the bigger picture of things, we have things that are hypotheses, and we have things that are proof, and we have things that are laws. Okay, so I have a hypothesis, and the hypothesis is all the females in the class are getting an A. Okay, and then I have a proof. A proof, and the proof is the last 7 years of classes, all the females I teach get A's. Okay, so that'd be the proof, and then there'd be a law. Now, this guy here doesn't have to be right. That guy doesn't have to be right. Laws not only have to be right, but they can't be broken. Okay. So name me a law.
Yeah.
That's correct. Very good. Ohm's law.
Yeah.
Oh, there you go.
Oh, yeah.
Is that how you spell ohm?
Eli.
Ohm's law. V is equal to IR. That is a law.
Always.
It is true here. It is true on the sun. It's true in the middle of the sun. It's true in the middle of the galaxy. It's true as I fall into a black hole. It's true in the next galaxy over. And if there's a parallel universe, it's true in the parallel universe.
How can we test on that?
It is a law. Okay, so this is the law of sines. So the sine of A is equal to the sine of B is equal to the sine of C divided by A divided by B divided by C. Okay. Or you could write it A over sine A is B over sine B is C over sine C. Now, put on your mathematics hat. If I say A is equal to B is equal to C, what does that mean?
It means they're all equal to the same. They're all
Does this mean they're all equal to each other?
No.
No.
No. No, it doesn't.
So this guy can equal that guy,
Oh.
but this guy would be different. This guy could equal that guy, in which case that guy would be different.
Ah.
This guy could equal that guy, in which case that guy's different. So the law of sines is written in a peculiar mathematical way. We only use two of these at the same time. Okay. So now I've got a triangle. Okay. This is a regular old triangle, and we're going to label this side, this angle A, this angle B, this angle C. Normally, the A's and B's are smaller and the C's the big one, but it really doesn't matter.
Yes, that's correct.
We're going to go and label this guy little a, that's the length between C and B. So the side opposite the angle A is little a, the side opposite little b, big B is little b, and the side opposite little c is little c. So now I'm going to go and I'm going to put an altitude in. Anybody know what an altitude is? Yeah. So I'm going to bring a line from C down to there, and it's going to be a right angle. And that's going to, we call that an altitude, and it's going to have the height h. Okay, so we're going to do that. And then I'm going to ask you the question, what is the sine of A? And you're going to say, well, the sine of A is the side opposite over the hypotenuse. right? And then I'm going to ask you, what is the sine of B? And you're going to say, well, that's the side opposite, which is h, divided by the hypotenuse A. And then you're going to say, well, look at this h. H is equal to B sine, if I could spell sine, A. And I look over here and I say h is equal to A sine B. Now, isn't the two h's, aren't they the, if I could write an h, the two h's are the same thing, right? So B sine A, it has to be A sine B. I can cross multiply and have A divided by sine A equal B divided by sine B. I could do that, right?
Sure.
Yeah, why not? And then I could go back and I could say, I got this triangle. Here's A, here's B, here's C, little a, little b, little c. Okay. Now I'm going to draw an altitude from B. I'm going to draw an altitude going to C. So I make a dotted line coming that way. And then I throw in a line that comes up that's at a right angle, like that. And I mark this guy H. Drawing's pretty bad, right? And I say, what is the sine of the C guy? And it's going to be H over A. Sine C, H over A. H over A. It can't be H over A. H, it's sine of C. C over H. Maybe. And then I'm gonna do the same thing with the B guy. Sine of B
So
is
it's equal to C over H.
B
Yeah.
over H. And then I'm going to put my H's equal together. I'm going to C over sine C is B over sine
What's the second one?
B.
Is it B over H or H
Oh,
over
who
B?
cares?
Sine B.
That's an H.
And the next one.
This is a C. The H is on the bottom.
Okay, that's what.
Now, that's a B. But in both of these examples, the H's are different, right? Yeah, so the H's are different. Oh, you want me to move up? Is that far enough?
Like that's sine C. Is it H over H?
B over H.
B over H.
It's
Yeah.
purposely confusing.
Yeah.
B over H. Right. But in both those examples, the H was different. Okay, so I write my law of sines the way I do with two equations in it, but I remember that when I use it, I'm only going to use one equation at a time. Okay, so that's what I'm trying to make out here. All right, now, if I have a right angle, am I ever going to use the law of sines? And the answer is no. So the only time I'm going to use the law of sines is if my triangle is not right. So it's not a right triangle. That's the only time I'm going to use it. All right. Well, let's say that let's say for a moment that I've got this triangle, A, C, B, A, B, C. Okay. I know this guy. I know that guy. I know that. All right. So I know big A. I know little c. I know little b. All right. And then so I look at my formula and I say, okay, I got sine A. I got sine B. I got sine C. And I know little b, little a. I know those guys. I know side, angle, side. Okay, that's what I know. All right, so I write the first guy, A over sine A. I know this guy. Good. Is equal to b over sine b. What is that? What do you call this equation?
I think so.
One equation, three unknowns. Can you solve one equation, three unknowns? Bummer. In fact, no matter what I do with this combination of things, I'm going to have the same thing. I'm going to have one equation, three unknowns, and I won't be able to solve it. So, and if you think about this guy for a little bit, I know the angle in the two sides. You'll probably figure out why. Well, anyway, so that means what?
Close.
Yeah, that means you're hosed. How about if you had, we got another guy. So we come back and here's A, B, C. I know those guys, but I don't know any of the sides at all. Okay, so I look at A over sine A, and I look at B over sine B. What do we call that? One equation, two unknowns. Can I solve one equation, two unknowns? No, I can't do that either. Bummer. All right. So if I have a triangle that's, I know all three sides of the angle, angle, then I can't use the law of sines. It isn't going to work. If I have side, angle, side, it's not going to work. Okay. How about side, side, side? Will it work with side, side, side? And it may not work with side, side, side either. Probably does. I don't know how. But anyway. But luckily we have section 11.2, which is law of cosines, which we use to solve the other part. Nice. Anyway, so that's all there is. Oh, right there. Side, side, angle, angle, side, whatever. All right. Enough of that. Turn the page, turn the page. Okay. I'm doing number 2. I got a triangle. I got A, B, C, little a, little b, little c. And then I look at my data. 30, 50, 57.5. 166 miles. 151 miles. Okay, that's what we know. We want to know what A is, what B is, and what little a is. Okay, so those are the three things that we're supposed to solve. All right, so we make a law of sine things and say 166 sine 57.5 is equal to 151 over sine b. Now this equation is known as one equation, one unknown, so I can solve it. So cross multiply some sine b is equal to 151 sine 57.5 divided by 166. B is equal to the arc sine of 151 sine 57.5 divided by 166. So now it's time to turn on my calculator, which won't turn on because I probably don't have enough power. All right, so arc sine of 151 times the sine of 57.5 divided by 166 close parentheses equals. Bummer. Left out of parentheses. All right. Oh, maybe. Is it 49.6?
What?
49.6 degrees. Okay, so I come back up here. B is 49.6. We know what, who, where.
I got 50.1. That's what I got. Yeah.
Did I fat finger a key?
Most likely.
All right, I'll try again.
You do have to have it in degrees, not.
Yeah, I'm in degrees, I hope. So sine, arc sine 151 times the sine 57.5 close parentheses divided by 166 close parentheses equals 50.1. I agree. 50.1. That's why you guys are supposed to be using your calculators so that I can get it right. 50.1. Now, we remember from 7th grade that the summation of the angles have to be 180. Okay, so if I take 180, subtract minus 57.5 minus 50.1, I will get A. 180 minus 50.1 minus 57.5, boom, I get 72.4. Okay, so now I know A. I need to find little a. Need to find little a. All right, so I'm going to take C, 166 divided by the sine of 57.5 is equal to little a divided by 72.4. And I'm going to find that A is equal to what? What are you confused about?
We get 72.8 on the last one that you did. Not 4, 7.8.
Because you're using your inspire, that's why.
Oh, no, I got 72.4.
That's what
One guy.
Here's a 5. There's a 1. That's 0.6. I better get 0.4. You know, when you have a $200 calculator and you can't make it work, what can the instructor do other than make fun of you, you know? That's about it. That's about all. Anyway, are you better now?
Yeah, I got it.
All right, so A, we're going to cross multiply.
That finger.
72.4 times 166 divided by the sine of 57.5. Okay, 166 times. What is in the world? Who left the sine off of this? How am I supposed to get the right answer if I don't put sine on there? Sine, where was I? Sine 72.4 times 166 divided by 57.5. Boom. Minus, oh, bummer. Clear the whole darn thing. All right, where'd it go? Sine, I didn't put a parentheses in. 72.4 close parentheses times 166 divided by sine 57.5 close parentheses, boom. 187.612. Okay, how many significant digits do you think we have? 3. Okay, so we'll make that 188 miles. Okay, now are we right? Well, we don't know. We'd have to look in the back of the book, right, or something. But Idiot Check says the smallest angle should be the smallest should be the smallest length. So 50.1 is the smallest, 57.1 is a little bit bigger, and the 72.4 is a little bit bigger. So the Idiot Check says we have it right. The bigger the angle, the bigger the side. Go which way? That far enough?
Yeah.
So we're going to do this over and over and over again until we get it right. Let's do,
Right?
huh? We'll do number 8 next. 8.
Número 8.
Number 8. All right, so I got, I draw a triangle again. I got an A, I got a B, I got a C, I got an A, I got a B, I got a C, and then I look at my data. 16.4, 205 feet, B, 187 feet. Okay, so we'll go for big B first. 205 divided by the sine of 16.4 is equal to 187 sine B. Okay, doing some cross multiplying, we say B is equal to the arc sine of 187 divided by 205 times the sine of 16.4. Hope we have enough parentheses. All right, so arc sine 187 divided by 205 times sine 16.4 close parentheses equals 14.9. So B 14.9 degrees. Well, if this is 16.4 and that one's 14.9, then this guy had better be 180 minus those guys, right? So 180 minus the answer minus 16.4, 148.7. 148.7. Okay, well, do it again. 205 divided by the sine of 16.4 is equal to, I don't know, or do I know? No, I don't know, divided by the sine of 148.7. Cross multiply and I get C is equal to, that's a little c in case anybody was wondering. Little c is equal to sine 148.7 sine 16.4 205. That begs the issue, can I make a triangle that doesn't make it? Could I tell you this is 45 degrees and this guy over here is 85 degrees, this guy's 10, this guy's 15, and this guy's 2? I certainly could. And it wouldn't hook up, right? So because we're in section 11.1, all my triangles are real, but look at the name of 11.2. Ambiguous case.
No way.
I could also go and have one. Let's say that I didn't do this. I have a 10 there. Could I not take a compass and do something like this and have two things here the same length and have two different triangles? Yeah, I could. So there might be another answer. Because this is 11-1, there's not a second answer. We don't have to look for it. Next section, which happens in about 2 minutes or so, we're going to have to look for the other answers. All right, so let's look at C here. The sine 148.7 divided by the sine of 16.4 times 205. Boom. 377. 377. So we expect the biggest angle to be the biggest side. and we expect the smallest angle to be the smallest side. Looks like we're there. 377, that doesn't leave much left over, right? So this guy looks sort of like this, right? It's a squished down guy, big angle there, little angles there. That reminds me of another rule that we're not going to cover today. Yes? Problem in the back row? No, probably not. All right, so that was 8. Do we see a hard one we can do? Number 20? We'll do number 20. Number 20. Okay, we'll start the same way. A, B, C, A, B, C. Does it matter if I start A here or A someplace else? No. No, it doesn't matter. Okay. So B is 75 degrees, 30 minutes, 6 seconds. C is 70 degrees, 12 minutes, 18 seconds. And little c is 93.45 meters. All right, so what are we going to do? We're gonna take the minutes, degrees, seconds thing and change them to decimal degrees. That's what we're going to do. And the first place we're going to do is look to see if that's on our calculator someplace, because it used to be there. Huh? You see it?
Under math.
Under math? Math. Right there. Decimal degrees, minutes, seconds. Okay, so that's what we're going to do. We're gonna go and enter our degrees, minutes, seconds, and it'll probably just change it for us. But how do I get degrees? There it is. I see it. Okay, so I'm going to get out of there. Okay, so I'm going to take 70 math, degrees, minutes, seconds, degrees, and then I'm going to take 12 second function math, not second function math, you idiot. How do I go back? Degrees, minutes, seconds, I want there, okay, and then I want 16 math, and I want there. Okay, so this guy becomes, after I push enter, C becomes 70.205. Okay, so I can do it on my calculator. The other thing I could do is I could go 75 plus 30 over 60 plus 6 over 60 squared. So I could do that too. So I'm gonna do that for the next guy, because that might be easier. Plus 0.5 plus 6 divided by 60 squared, boom. And I'd end up with 75.67 repeating. Well, 0.66 repeating. Okay, now knowing that, I can calculate A. So I'll calculate A. 180 minus 70.025 minus 75.666666666. 34.128. 128. 3. Right there, I got them written down there. 180 minus this minus that. All right, now I want this in degrees, minutes, seconds. So A in degrees, minutes, second is going to be 34 degrees. Okay, so I got 34 degrees. Then I'm going to take the 0.1283 and I'm going to multiply that times 60. And I'm going to say that's 7 minutes. And then I'm going to subtract that 7 from it, minus 7. And I'm going to multiply that number times 60. And I'm going to get 42 seconds.
How'd you get 42 seconds?
Can you put it on writing on there so I can see the process of how to do it?
All right, so I've got 34.1283. Okay, so I'm going to keep the 34 degrees. I have 0.1283 left over. I'm going to multiply that times 60. And I'm going to get a number, 0.1283 times 60. And I'm going to get 7.698. So I'm going to write down 7 minutes, if I could remember how to spell minute. That's better. And then I'm going to subtract 7 from that and give me 0.698 left over. I'm going to take that 0.698, multiply it times 60. I'm going to go minus 7 equals times 60. And I'm going to get 41.88. And I'm going to write down 42 seconds. Okay, so just like when I had 75 degrees, 30 seconds, 30 minutes, 60 seconds, I said 75 plus 60 divided by 30 plus 6 divided by 30 squared. Now I'm multiplying to go the other way. Okay.
Thank you.
So now I've got A, I got B, I got C. I'm still looking for little b, and I'm still looking for little c. Now I'm sure that I could put this in degrees, minutes, and seconds using those symbols in my calculator in a sine thing to get the right answer, but I like decimal degrees better. Okay, so now we got to remember what we're doing. Like, what problem are we doing? All right, so I've got 93.45 meters divided by the sine of 70.208 is equal to A divided by, was it 205. 205, the sine of A, and A was 34.1283. 34.1283. Okay, so little a is going to be sine 34.1283 divided by sine 70.205 times 93.45. Sine 34.1289 divided by sine 70.205 times 93.45. Little a is 55.7. Anybody know what these guys are in? Miles. And I'm going to go 2 miles because I seem to have that many significant digits. No, it's not. It's in meters. 2 meters. Okay, so now I got little a. Now I'm going to look for little c. 93.45 meters. Sine 70.205. I got little c?
Yeah.
So I'm looking for little b.
Little b, yeah.
B, 75.6 repeating. Sine 75.6 repeating. Okay, so B, sine 75.6 repeating divided by sine 70.205 times 93.45. Sine divided by sine times 96.23. 96.23 meters. So that's my B. 96.23. What was my A? 55. 55.72. So the littlest angle gives the smallest number. The biggest angle gives the biggest number. Idiot check works, and we're done with that. Okay, moving on to 11-2. Now, the only difference in 11-2 is there might be a second answer. So, we remember that the sine function looks like this, and the arc sine function is only going to give you answers in the first quadrant. So if there is a second quadrant answer, when I take the arc sine function, I'm not going to see it. But there could be one, so I have to go back and look. Okay, so that's the whole principle involved. Well, we're going to look at, well, your arc sine function only gives you answers between minus pi over 2 and pi over 2. But the sine function is positive in the first and second quadrant. So if I say 1/2, and I take the arc sine of 1/2, I get 30, but that's only this answer. There's another answer over there of 150. So if I take the sine of 150, what do I get? Sine 150, boom, 30, 1/2. So sine of 150 is 1/2, sine of 30 is 1/2. So if I have a triangle that would, and I have this angle that could be 30 or could be 150, I have to look at both of them. Okay, so that's the issue. What's your issue there, Raimundo?
No, I was just asking about the quadrants. I thought the quadrant 1 was always on the right, and then it goes 2, 3, and 4. But you have the other ones. You can't use 3 and 4.
Okay, so Raimundo's issue is, this is the x quadrant, that's the y quadrant.
Yeah.
This is the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant. How many believe that that's the case, that Raimundo is not hosed, and that is in fact true? Okay, one of you, excellent. 2 of you, excellent.
So we're
Okay.
hosed.
So, there's nothing wrong with that. Now, if I draw the sine function does this. And it goes from plus infinity to minus infinity. It just keeps on going.
Yeah.
Okay? But my first quadrant is there. And my second quadrant is there. And my third quadrant is here.
Oh, I see.
And my fourth quadrant is there. And then I'm back to the first quadrant again. As I rotate the unit circle, rotates around there. So I've got this guy's rotating around there, roundy, 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 but he's also going up and down, up and down, up and down like a sine wave while he's doing that.
I got it now.
Okay.
Thank
So
you.
that's why I'm saying there's a first and a second quadrant answer to 1/2.
Thank you for explaining that.
Yeah. I have other ways to explain it too, but they're much more complicated. Number 2. Yeah. Number 2. Okay, so I got this thing. Boom, boom, boom. And A, B, C, A, B, C. This is 55 degrees. 182. 203. Okay, so I'm looking for big A, I'm looking for big C, I'm looking for a little a. That's what I'm looking for. Okay, so we're going to look for big C first. So 203 divided by the sine of C is 182 divided by the sine of 55. C is equal to the arc sine. The arc sine of, cross multiply, 203 divided by 182 times the sine of 55. 203 and I get 66 degrees. All right. So big C can be 66 degrees. If that were the case, then I can have 180 minus 66 minus 55, and this is going to be 59 degrees over here.
That's to get the A.
So A is 59, C is 66, and now little a, the little a divided by the sine of 59 would equal 203 divided by the sine of 66. That's bad. Don't want to do that. Bad math. Bad. We don't want to use what we calculated in our answer if we don't have to. So what were we given? We were given B. Okay, so we're going to use B's instead. 182 divided by 55, sine of 55. Implying that A is equal to. Okay, so sine 59 divided by sine 55 times 182. Boom, 190. 190. Now that's a perfectly okay answer. But we have to ask ourselves, is there a possibility of a second answer because we're in section 2 of the stupid book? Okay, and they may have put a ringer in there for us. So when we come back to C being 66 degrees, we can say this 66 degrees is just a reference angle. What is the second quadrant answer? So it'd be 180 minus 66. That'd be 114 degrees, right? So C could be 114. C could be 114. Okay, now if C were 114, what would A be? 180 minus 114 minus 55. It would be 11 degrees. So it is possible that C is 114 and this guy's 11, in which case what would little a be in that case? Well, little a divided by the sine of 59, not 59, 11. Sine of 11 is equal to 182 divided by sine 55, implying little a is is 42.4 meters. So there's two different answers. And both of them perfectly okay. So I could have an angle that's very flat, or I could have an angle that's more equilateral in nature. So there's two possibilities.
So if you write either answer on there, it's going to be correct.
No, you'd have to have both of them to have
Okay.
full credit. Yes.
So you just write two different.
Could you go down on the table, please?
So you'd have if you didn't bring your colored crayons, so you could do it in different colors like I did, then you'd have one set that says that, and another thing that says A is equal to 11, C is equal to 114, little a is equal to 42.4. So now I'm showing two different answers. So the issue comes down, when you calculate your first angle, is it possible that I have a second quadrant answer?
I'm just asking how you want it written down.
Yeah. Mm-hmm. And maybe I'll be very nice to you and indicate on the test that I've hosed you over, and there's two answers, go looking for both. But chances are I won't. I like taking points off anyway. And no one's going to flunk now, so it really doesn't matter how many points I take off anymore. All right. And the whole issue is, if this guy, he's 66, the other guy's 141, right? The second one. Let's say if this guy was not 66, but he came out to be 30 degrees, then the second quadrant answer would be 150, and I come back up here, 150 plus 55, that's greater than 200 already. I can't have that triangle. So that's how I would know that I only have one answer, because when I try the second one, it's not there. Okay, one more, and then we'll go home. We'll look at number 20. No, we won't. Yeah, we will. Yeah, we'll do number 20. 2 and 20, that should be good enough. So I got a triangle. A, B, C, A, B, C. 31.5. 375.0 millimeters. Oh, way to go. 405.5 millimeters. Okay, so I'm looking for capital B, capital C, little c. That's what I'm looking for. Okay. So I write 375 divided by sine of 31.5 is equal to 405.5 divided by sine B. I come up that B is equal to the arc sine of, cross multiplying, 405.5 375 sine 31.5. Arc sine of 105.5 375 sine 31.5 close parentheses equals 34.4 degrees. So I got 34.4. I'm going to take 180 and I'm going to subtract that answer, and then I'm going to subtract another 31.5, and I come up with C is 114.1. Okay. And then I'm going to say 375 divided by the sine of 31.5 is equal to little c over the sine of 114.1. And I'm going to say c is equal to. Okay, so sine of the answer divided by sine 31.5 times 375. 655. So little c is 655 point something, right? Yeah, we need another significant digit. 0.2, 0.655.2 millimeters. 655.2 millimeters. We idiot check the answer. This guy's 114.1 degrees. This guy's 34.4. The biggest angle is the biggest guy. The smallest angle is the smallest guy. Idiot check works. There's nothing wrong with that answer. Then we go back and say, well, what if this this angle B that we calculated first, what if it were only a reference angle? And the answer is really a second quadrant answer. So the second quadrant answer would be 180 minus 34.4. Okay, so 180 minus 34.4 would be 145.6. So what if B was really 145.6 degrees? 145.6 degrees. What if he was? Well, if he was, then C would have to be something different. 180 minus 31.5 minus 145.6, 2.9 degrees is all that C is. Okay, so now I've got a new answer that says B 145.6 degrees, C is 2.90 degrees. Okay, and now I've got to find little c. So 375 divided by the sine of 31.5 is equal to little c divided by the sine of 2.9, implying little c is equal to the sine of 2.9 divided by the sine 31.5 times 375 equals 36.3 millimeters. Little c, 36.3 millimeters. 36.3 millimeters. Now, idiot check. The smallest angle is the smallest guy. The biggest angle, idiot check fails. Did we have to calculate B? No, oh, wait a minute. Which problem am I doing? 20. No, we're given B. Okay, the biggest angle is the biggest guy. The next biggest angle is the next biggest guy. And the itty-bittiest angle is the itty-bittiest guy. So yeah, we're fine.
Hey, on the last step you did a sine 2.9 over sine 31.5 and then sin
Yeah.
What?
What?
On the last answer.
What I do?
6.3.
I said C was equal to the sine 2.9
Yeah.
sine
Divided by
31.5 times 375. So I'm cross multiplying. I'm just sending that over there. Yeah. Okay. Any questions? No questions. Control.